All right, this is lesson 3.2, and I'm going to break this into two parts. So the first part we're going to do here is going to be graphing. So we are going to solve a systems of equation by graphing. And what we have here is when I have a system of anything, a system of equation is going to mean more than one line. That's what the system tells me. So when we solve a system by graphing, what we're trying to do is find all points of intersection. When I have two lines, like I have right here, these points of intersection are going to tell me what my solution is. And so we're going to look at three different cases to answer this question. How many possible points of intersection for two lines? So how many solutions are there? So the reason we spent so much time graphing in the last unit was for this kind of a lesson. So the first thing that I'm going to do, I'm going to graph this as two different colors, is I'm going to graph this first line. And this is already in the form y equals mx plus b. So what I know is I'm going to start at 3, and I'm going to go down to over 1. And I'm actually going to use a ruler on this, because the point of intersection is so important that I have my line that looks like this. And now I'm going to, hold on, I'm grabbing another pen. I'm going to create another line, and that I'm going to make this my orange line. And this line, I start at -2, and I go up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to graph this line now. And so I have these two lines, and I have a point of intersection. So it's right here. It is not a pretty point. It doesn't fall on, nice cross-hatch lines. So this point would be like, I don't know, 1.6 and -0.25 or something crazy like this. But because these intersect, I have one solution. Okay, we're going to do it again. We're going to graph this line. So I start at 3, and I go down to over 1, so that line's looking something like this. So just like the previous line I just had. So let me graph this guy. And now I'm going to graph this orange line. So I start at -2, and I'm going to go down to over 1. I'm going to go this direction so I have more points. And here's my other line. Okay, so here's what happens. I have this purple line, and I have this orange line, and those two lines have no intersection. So because they're parallel lines, that's what these are, so they're parallel lines, and there's no intersection, this means there's no solution. There's no place where these two lines are ever going to intersect. All right, let's do this last one. So this last one, again, 3, down 2 over 1. So I have this same purple line right here. And now, when I solve this, I have this 2 that's out here. So I have to divide this by 2, and divide this by 2, and divide this by 2. And what I get is y equals -2x plus 3. So I start at 3, and I go down 2 over 1, down 2, down 2 over 1. I graphed that point wrong. Darn it. So what ends up happening here is that this point of this line, these two lines, I just made a mistake because I graphed this one point wrong here. These two lines overlap. And when I have lines that overlap, I have infinite solutions. And so sometimes we write this as all real numbers, or you can say infinite solutions. Because this should be, if I would have done this correctly with my purple line, this is the same line. You can see here I have -2x plus 3, -2x plus 3. So it's the same line. That line overlaps, so we have infinite solutions. Okay, so first method for solving a system is graphing, but graphing only works when you have graph paper. So if you don't have graph paper, the next way that we're going to solve this is with substitution. And so we have some strategies right here. And so what's going to happen is we're going to solve for one variable. So we're going to have two equations, that hasn't changed, but we're going to solve for one variable. We're going to, here's the key word, substitute that variable into the other equation. We're going to solve that equation, and then we're going to, here's our word again, substitute the first equation to solve for the other variable. So what I'm going to do here is, this word substitute, kind of a cheat for this is plug in. And we say this sometimes, we're going to plug it in for the other variable. So when I say substitute, we're going to plug it in. All right? So here's what happens. I have this equation, and I could solve for this x, this y, this x, or this y. What I want to do is I always want to solve for a variable that doesn't have a coefficient. So I'm going to solve for this y. So I have to move things over. That's why lesson 3.1 was so important, because I have to isolate this and get it to be just y equals. So I have negative y equals negative 2x plus 11. I took this 2x and move it to the other side, but this is still a negative y, so I have to divide by negative 1, negative 1, negative 1, and now I end up with y equals 2x minus 11. Okay, that doesn't tell me anything. So I'm going to take this, I solved for the first one, and if we look here, substitute into the other equation. So here's the other equation. Here's y. Here's y. This is what I'm substituting for. So I'm going to write it this way. 3x plus 2 parentheses equals 6. If this is y, where I put parentheses is the y in this equation. And I did that for y because this equation is already y. So now I'm going to take that, this guy right here, and I'm going to plug it in. So I just substituted y in for this y, and this is what my equation looks like. So at this point, I'm going to solve. So 3x plus 4x minus 22 equals 6. I distributed this 2. Here's what I end up with. This is on the same side of the equal sign. So when it's on the same side, we combine like terms. 7x equals 28. So x equals 4. So now that I have x equals 4, I'm going to substitute. So that's what we did. We solved the equation. And now we're going to substitute into the first equation. So I'm going to take this value of x equals 4, and I'm going to substitute it back in here. So I have y equals 2 times 4. I think I said negative 4. It's a positive 4. 2 times 4 minus 11. So 8 minus 11. So y equals negative 3. So I have my x value, I have my y value, and we are always going to list these as ordered pairs. So my solution here is 4, negative 3. Okay? All right, we're going to do one more substitution. It's on the other side right here. So solve the system by substitution. So if I look at this, remember I want to solve for the variable that doesn't have a coefficient. That's this x. So x equals 2 minus 6y. Now I go, this is x, this is x. I go back to the other equation. So I'm going to write this 5 parentheses plus 4y equals 36. And y'all, I really want you to do it this way. I want you to look at your equation. I want you to put parentheses and then go back and substitute. So 2 minus 6y falls in there. Now, all you can have are y's. If you end up with an x anywhere in here, you did something wrong. So I'm going to distribute, and I have 10 minus 30y plus 4y equals 36. So I subtract over here, same side of the equation, so I'm just doing combining like terms, so negative 26y equals 26, so y equals negative 1. Okay, So I'm going to take this, plug it back in here to solve for x. So x equals 2 minus 6 times negative 1. 2 plus 6, so x equals 8. All right, so my ordered pair is 8, negative 1. Now, be careful. I solve for y first. So when I put my ordered pair, I have my y and my y term. Remember, this is my x component and this is my y component. When we solve this one first, we solve for x. X was 4. It was the first one I solved for, so it's here. But it's because this is x, and this is y. So if you end up solving for y first, make sure that you write your ordered pair correctly. X is always before y. Okay, I'm going to go ahead and make a different video for elimination.